This topic is about writing expressions in index form and also about solving equations with indices. I will go through multiple examples, so feel free to pause whenever you want. First few examples are all about writing expressions in the form kx to the power of n. Now in the first example, I've got 5 times root x, which can be rewritten as 5x to the power of a half, as root x is the same thing as x to the power of a half. In the second example, 1 over x to the power of 4, because x to the power of 4 is in the denominator, this is the same thing as x to the negative 4. Okay, 3 over x. Okay, if I separate the numerical part from the algebraic part, it's the same thing as 3 times 1 over x. 1 over x is the same thing as 1 over x to the power of 1. So the numerical part stays the same. 1 over x to the power of 1 is the same thing as x to the negative 1. So that is in the correct form now. 1 over 3x, if I separate out the numerical and the algebraic part, 1 over third times 1 over x. Again, the 1 over x is the same thing as 1 over x to the power of 1, which can be rewritten as a third times x to the negative 1, as x is in the denominator, which can be simplified to a third x to the negative 1. So that is now in the correct form. 4 over 3x squared can be separated into 4 over 3 times 1 over x squared, which is the same thing as 4 over 3 times x to the negative 2, as x squared is in the denominator, which is 4 over 3 x to the negative 2. 5 over x to the power of 4 can be separated into 5 times 1 over x to the power of 4. Again, because x to the power of 4 is in the denominator, that can be rewritten as x to the negative 4, which simplifies to 5x to the negative 4. Okay, 1 over 4x to the power of 8 can be separated into a quarter times 1 over x to the power of 8, which can be rewritten as a quarter times x to the negative 8, as x to the power of 8 is in the denominator, which simplifies to a quarter x to the negative 8. Root x over 4 is the same thing as a quarter times root x. Root x is just x to the power of a half, so it's a quarter times x to the power of a half, which simplifies to a quarter x to the power of a half. Okay, the last 4 example. This example separates up into a fifth times 1 over root x. A fifth times 1 over root x is the same thing as 1 over x to the power of a half. Because x to the power of a half is in the denominator, that can be rewritten as x to the minus a half. If I separate out the numerical and algebraic part of this example, same thing as 4 over 5 times 1 over cube root of x. 4 over 5 cube root of x can be rewritten as 1 over x to the power of a third. And because x to the power of a third is in the denominator, it can be rewritten as x to the power of minus a third. Eight over 3 root x can be separated into 8 over 3 times 1 over root x. Again, 8 over 3 times 1 over root x can be rewritten as 1 over x to the power of a half, which in index form is the same thing as 8 over 3 times x to the negative half, as x to the power of half is in the denominator. Now the last example of this type, if I separate out the numerical part from the algebraic part, I get 16 over 8 times x squared over cube root of x. 16 over 8 simplifies to 2. X squared in the numerator stays the same. Cube root of x can be rewritten as x to the power of a third. 2 again stays the same. Because we're using indices, laws of indices tells us x squared divided by x to the power of a third, the same thing as x squared take away a third, which is 2. X 2 take away a third is the same thing as 5 thirds. So that would be in the correct form now. So those were all examples of writing expressions in index form. Now we'll be looking at solving expressions with, obviously, indices. Now there are two different cases that we're looking at. The first case is when x is in the base number. So I'll go through two different examples here. So we've got 3x to the power of a half is equal to 24. Now BIDMAS tells us that when we look at the journey of x, first we are raising it to the power of a half, and then we're timesing by 3. So index, and then we're multiplying it. So when we're undoing it, the first thing we need to do is divide by 3. So if we divide both sides by 3, I get x to the power of a half on this side is equal to 24 divided by 3, which is 8. Now we've got x to the power of a half. What's the opposite of half? Raising it to the power of a half is squaring it. So x to the power of a half, if I want to get rid of this half in the index, we need to raise it to the reciprocal of a half, which is 2. Now if we do that on the left hand side, we need to do the same thing on the right hand side. So we've got 8 squared on the right hand side. So these two cancel out, so all we're left with is x on this side. 8 squared is 64, so that would be the final answer. But the same thing for the second example, x to the power of negative 5 over 3 is equal to 32. Now when I look at this question, the first thing I want to get rid of is that negative. So if I want to get rid of the negative, I will raise it to the power of negative 1. So raise it to the power of negative 1, but also I need to raise this side to the power of negative 1. Now when I raise the left-hand side to the power of negative 1, I end up with x to the power of 5 over 3. Because when you multiply the two numbers together, negative 5 over 3 times negative 1 gives you positive 5 over 3. 32 to the minus 1 is equal to 1 over 32. Because the negative 1 means the 32 goes in the denominator. Now I want to get rid of this 5 over 3 in the index. In order to get rid of that, I need to multiply this, x to the power of 5 over 3, by its reciprocal, which is 3 over 5. So flip the fraction over. Because I've raised it to the power of 3 over 5 on the left-hand side, I need to do the same thing on the right-hand side. So the whole point of doing this is getting rid of these indices. So I'm left with x on this side. 1 over 32 to the raised to the power of 3 over 5 is the same thing as first fifth rooting 1 over 32 because 5 is in the denominator, and then cubing it. Now if I do that correctly, x will be equal to the fifth root of 1 is just 1. So it'll be 1. And the fifth root of 32 is 2 because 2 to the power of 5 is 32. So half, I need to cube it. Now cubing it means I do 1 cubed at the top, which is 1. And 2 cubed is 8. So that would be a final answer for that one. Okay, and the last set of examples is when x is part of the index. So we've got 3 to the power of 2x plus 1 is equal to 9 to the power of 2x minus 1. Now in these questions, what we have to realize is we need to write these in the same base. So 3 and 9, we could definitely write it in base 3. So if we want to rewrite it in base 3, 3 to the power of 2x plus 1 stays as 3 to the power of 2x plus 1. But 9 can be rewritten as 3 squared to the power of 2x minus 1. Because 9 is the same thing as 3 squared. That means 3 to the power of 2x plus 1 is equal to 3 to the power of 2 times 2x minus 1, according to the index law. Now, because both of these are base 3, we can equate the indices. So we end up getting 2x plus 1 must be equal to 2 times 2x minus 1. If I expand the bracket, I get 2x plus 1 must be equal to 4x minus 2. If I collect the x's on one side, I get 4x minus 2x must be equal to 1 plus 2, which means 2x must be equal to 3, so x must be equal to 3 over 2. In the second example, we've got base 4 and base 8. Now what we have to realize is 4 and 8 can be written in base 2. So if we have 4 to the power of 2x plus 2 is equal to 8 to the power of 3x minus 2, 4 can be rewritten as 2 squared. And 8 can be rewritten as 2 cubed. Which means 2 to the power of 2 times 2x plus 2, because we're using laws of indices, must be equal to 2 to the power of 3 times 3x minus 2. Now again, we have base 2, everything in base 2, so now the indices must equate as well. So 2 times 2x plus 2 must be equal to 3 times 3x minus 2. If I expand the bracket, I get 4x plus 4 is equal to 9x minus 6. If I collect x's on one side, I get 9x minus 4x must be equal to 4 plus 6, which means 5x must be equal to 10, which means x must be equal to 2. And that would be my solution.